Hello, once again, chemistry students. It's your favorite professor, Professor TK the Chemist. And today I'm going to share with you guys another tip and trick on how to understand these gas laws. Next up, Gay-Lussac's law. Okay, let's get into it. All right. So here we see Gay-Lussac's gas law indicates that as the pressure and temperature go up, they are directly proportional to one another. So in other words, pressure and temperature are directly proportional because they do the exact same thing. If the pressure drops, so does the temperature. Watch out for your temperature. You want to make sure that your temperature is always in Kelvin. Okay? Here's a problem that we're going to get into today that deals with Gay-Lussac's law. And it reads as following. A gas has a pressure of 1.5 atm at 300 Kelvin. If the temperature increases to 600 Kelvin, what is the final pressure, assuming constant volume? Now, here's one thing you need to know. Whenever there are variables that are constant, that means they do not play a role in the actual problem itself. So for this particular case, we can kind of dismiss the volume and just focus solely on pressure and temperature. The first pressure reading that you got was 1.5 atm. The first temperature reading was 300 Kelvin. And the first temperature, or the second temperature reading was 600 Kelvin because they told you it increased. So you're looking for P2. They also said, what is the final pressure? So our formula is P2 equals P1 times T2 divided by T1. So in this particular case here, before we actually solve the problem, let's take a look at what we can predict the answer to be. If you notice here, your temperature actually increased, right? It increased, it went from 300 Kelvin to 600 Kelvin. Therefore, we notice that our temperature doubled. So guess what your pressure is going to do? It's going to also double. So we can automatically know that doubling 1.5 gives us 3.0 atm. But if you want to see the numbers in place to prove that that's your answer, let's go ahead and put in the numbers here. So the first pressure reading was 1.5 atm times T2, which is 600 Kelvin, divided by T1, which is 300 Kelvin. And all we have to do again is just get rid of our kelvins in terms of the units that we no longer need. All right. Now we're going to go ahead and plug this into our calculator. 1.5 times 600 divided by 300 gives us 3.0 atm. So the correct answer is letter A. Stay tuned because the next gas law that we're going to get into is the ideal gas law. Is it ideal? Let's see. Okay, so stay tuned for that next gas law coming up. And I'm going to show you all some tips and tricks on how to actually solve the ideal gas law problems.